we are pleased to present a project about improving the technology for the disposal of hazardous waste from mining and processing plants using a soil nitrogen-fixing cyanobacteria. The idea for the project came about when a study of soil algae revealed a bright stimulating effect of cyanobacteria on plants. It was decided to create biological products to improve plant growth processes and use them to increase the efficiency of the technology to prevent the spread of toxic radioactive waste from the mining and processing plants. The innovation is that we first create original photobioreactor for the industrial cultivation of cyanobacteria because there was no ready-made solution. Second, no one in the world has produced any product based on this facility so far. The problem of industrial waste disposal is acute all over the world. In Ukraine alone, this waste covers 165,000 hectares of land. Waste from mining and processing plants is particularly toxic and hazardous, and their operations are increasing every year. So, let's summarize. Waste or sludge is harmful for all living things and its amount is constantly increasing. Sludge have a fine dust fraction and carried by a wind for tens or hundreds of kilometers. In people and surrounding areas, the incidence of morbidity, in particular the percentage of oncology, increases sharply. Another related problem is soil contamination as a result of military operation on the territory of Ukraine and environmental disaster caused by explosion of Kakhovka hydroelectric power station. Currently, to prevent the spread of toxic radioactive waste by wind, sludge pits are sown with herbaceous plants so that the root system can hold the upper layer together. However, some seeds don't germinate in such conditions, while another die in the first days or weeks. Our products stimulate seed germination. Plants withstand harsh conditions develop and remain alive for the months. The efficiency of the existing technology is improved many times over. By the way, our cyanobacterium is the first to colonize lifeless substrates and considered the most promising object for the settlement of Mars. We have simulated the modern sowing technology using mining and processing plants in the laboratory. We used sludge from Poltava mining as a substrate. In one of the variants, 2 glasses of the right, rye seeds were treated with the live cyanobacteria culture, and as you can see, the plant looks better. After washing, we can see bottom right that the root system is much better developed. With sorghum, which is also sown with sludge, we see that plants with our technology develop better and the root system is many times longer and more abundant. The sludge ponds also showed good result in the experimental site in the real conditions. The yellow plants on the left are sown using the classic technology, and the dark green ones on the right have a live culture of our cyanobacteria. This is what the experimental plot looks like directly at the sludge dump after 3 months. Only with our technology do the plants remain alive. In other options, they died. To solve the problem with the growing of our nitrogen-fixing cyanobacteria, we first developed a laboratory photobioreactor with a volume of 5 to 50 liters, those on the left. And now we have industrial 500-liter ones, the ones on the right. This is what our final product looks like. Today we have a production potential of 90,000 liters per year. Our biopreparat will cost for the end customer just under $7 per liter. We expect a profit of about $450,000 from sales in the next 24 years. Regarding the needs of the project, in terms of marketing, it is support of networks and website promotion. In terms of production, it is improvement and scaling. In terms of sales, it is the development of partnership and representative offices in the regions and scientific support. Approximately, it takes about $500,000. Our products are certificated organic. Here you can see a team of like-minded people who are passionate about the idea and they're implementing in fruitful